Some of them very likely have planets, and therefore I can imagine civilizations immensely beyond the capabilities of our own.
NASA just announced the discovery of 500 new planets. They're all orbiting other stars.
That's no, is it? It's not. It is on Earth, dude. Well, if there's another thing.
Brian Cox, a well-known British physicist, has recently announced that aliens might have been visiting Earth. Considering the vastness of space, it's hard to believe that we're the only intelligent life forms out there. Life on Earth has shown remarkable adaptability, like tardigrades that can survive extreme conditions, which hints that life could also exist elsewhere in the universe. We face two possibilities. Either we are the only intelligent beings, or we are not. Brian Cox encourages us to look at the evidence more closely and suggests that advanced alien civilizations might exist and could visit us soon. But is there real proof of these claims?
Can you do that? We've looked a bit, we've listened for radio signals from other stars, we've found nothing. We have no evidence of alien civilizations at all. That might mean we haven't looked hard enough because we haven't looked particularly hard. The galaxy is very big. But it might also mean that civilizations are rare. If you look at life on Earth, it began, we have good evidence, it was on the planet, let's say 3.8 billion years ago. So let's say it may have begun even 4 billion years ago, after the planet settled down and the oceans first formed. It took 4 billion years, let's say, to go from the origin of life to a civilization, which is about a third of the age of the universe. And if that's typical, and we don't know, then it may be that there are very few solar systems and planets and stars that are stable enough for that long to allow for evolution to do its work and for the single-celled things to go to multicellular creatures and plants and make an oxygen atmosphere and then make a civilization.
Our position in the universe is relatively calm. We orbit an average star with 8 planets, one of which is our home. For every grain of sand on Earth, there are about 10,000 stars in the sky, specifically between 10 to the power of 22 and 10 to the power of 24 stars. If 5% of these stars are similar to our Sun, that amounts to 500 billion Sun-like stars. Assuming that 1 in 5 of these stars has a planet in the Goldilocks zone, a region where conditions might allow for liquid water and life, there would be 100 billion Earth-like planets out there. If only 1% of the planets with conditions similar to Earth harbor life, then each grain of sand on Earth would represent an Earth-like exoplanet with potential for life. Given that there are about 100 billion stars in the Milky Way, this would mean there are over 1 billion Earth-like planets in our galaxy alone. If 1% of those planets have life, there could be between 100,000 and 1 million civilizations in the Milky Way. Despite decades of searching, SETI has not received any signals from these potential civilizations. This leads to the Fermi paradox. With so many stars and Earth-like planets, why haven't we found evidence of extraterrestrial life or heard from these civilizations? Recently, our understanding of habitable exoplanets has greatly improved, showing that such planets are quite common in the universe. We now know of about 3,800 exoplanets, some of which might support life. The TRAPPIST-1 system, for instance, has 7 rocky, water-bearing planets orbiting a star similar in size to Jupiter. These planets resemble Earth in many ways. Given the number of Earth-like planets, why haven't we detected another civilization? Despite ongoing searches for extraterrestrial life, our approaches often assume the presence of life elsewhere. For example, when astronauts returned from the Moon, they were quarantined for weeks. This precaution was based on the concern that even simple life forms, like bacteria, could pose a serious threat to life on Earth. The issue was significant enough that it continued to be a concern throughout the Apollo program, up until Apollo 15, when it was determined that the risk was manageable. However, this doesn't address the potential for human contamination of other moons or planets. There are thousands of pounds of debris left on the moon, and while it's unlikely, there is a possibility that bacteria could survive on this debris and become the moon's first life forms. To avoid such contamination, we send satellites to burn up in planetary atmospheres after use. Despite this, every prediction we've made about the universe has eventually turned out to be incorrect in some way. Throughout human history, there have been about 100 billion people. Almost all of our predecessors did not know what planets were or what the universe truly is. Nearly 99% of all species on Earth have already gone extinct. Could we be next? Centuries ago, we believed in a geocentric model, thinking everything revolved around us, and we thought the Earth was flat. Today, we know these ideas are incorrect. Given our history of mistaken beliefs, it seems unreasonable to assume we're the only life in the universe. Frank Drake shared this view. He believed that if we weren't alone, there should be a way to estimate where other life forms might be. This led to the development of the Drake equation. The Drake equation outlines the steps and conditions necessary for a civilization to exist and be detectable in our galaxy. It provides a method for estimating the number of such civilizations. In essence, it involves multiplying 7 variables to determine how many potential civilizations could be present in our galaxy right now. The equation breaks down into specific terms, starting with n, which represents the number of civilizations in our galaxy with which we might communicate. R** stands for the average rate of star formation in our galaxy. While we don't have an exact number of stars formed annually, we know that approximately 3 solar masses worth of stars are created each year, translating to about 3 average-sized stars forming annually. Our Sun is a fairly typical star, making it a useful reference. It might be a single large star or a group of smaller stars, but this term in the equation is the most certain. Fp represents the fraction of stars with planets, estimated to be between 10% and 50%. Ne is the average number of planets that could support life. So, we start by identifying stars, then find planets around those stars, and finally determine how many of those planets could support life. As mentioned earlier, about 1 in every 5 stars has a planet in the habitable zone, which is also fairly certain. Fl represents the fraction of those planets where life actually develops. Our data on life is extremely limited. Essentially, we only have information from Earth, despite the countless other planets. We rely on the data we currently have to make these estimations. What if extraterrestrial life doesn't operate like we do? It's possible, and even likely, that life beyond Earth doesn't always require water, oxygen, or sunlight. They don't have to function as humans do. With trillions of planets in the universe and a wide range of living conditions, it's reasonable to assume that there are many different ways alien beings could survive. Thus, estimating Fl, the number of planets with life, is challenging. Fi, the fraction of planets with life that develop civilizations, is also difficult to determine since our data is limited to Earth. I often wonder why, if we live on an average planet in an average galaxy around an average star, we're the only known life form. If everything around us is average, why did life appear here? Perhaps life itself isn't the anomaly, but rather intelligent life is. Humans are unique among Earth species for developing complex language and asking questions like, are we alone? Alien methods of communication might be beyond our imagination. They might not use language or rely on visual or sensory information in ways we understand, and they may not even have means to communicate with species outside their own. This is similar to how humans struggle to understand and speak whale. We lack the knowledge and ability to interpret their communication, and the same applies to extraterrestrial beings. On Earth, few life forms have verbal communication besides humans. When we discover ancient languages, we can decipher them by connecting them to known languages and sentence structures. With alien languages, there's no existing reference. While we can use human languages for comparison, trying to connect them to entirely different civilizations in distant parts of the galaxy may not be practical. FC represents the fraction of civilizations that develop detectable technology. Currently, humans are the only known example of this. If Earth were created just 1 year ago, humans would be about 10 minutes old, and the Industrial Revolution would have occurred only 2 seconds ago. For most of human history, we had no means of contacting alien life. Broadcasting radio waves into space is a very recent development, having started only 100 years ago, while humanity has existed for about 1 million years. This means we've had the capability to contact aliens for just 0.0001% of our existence. Moreover, radio waves are the only method we've used to attempt communication in the last century or two. We might discover a more effective way to contact extraterrestrial life, one that's far superior to radio waves. This could explain why we haven't received any responses. It's similar to trying to communicate across the world using carrier pigeons, while everyone else is on the internet. The assumption that all civilizations use the same technology as us might be flawed. We could either be the first to develop advanced technology or have fallen behind, with others progressing further. If extraterrestrials can detect our radio waves, they might have already discovered them. Additionally, every 4 computers now control essential vehicle functions. The last term in the Drake equation, L, reflects the duration of a civilization's existence and indicates how long we have to be detected before it's too late. Extraterrestrial civilizations might send out signals for a long time before they stop, destroy themselves, or transition to a different mode of existence, such as a simulation. The longer a civilization persists, the more advanced it might become. The Kardashev scale helps in understanding this progression. A Type 1 civilization is one that manages to control and utilize all the resources of its planet. Currently, we're around 0.72 on this scale. A Type 2 civilization, on the other hand, can harness the power of its entire star. Since Earth only receives a tiny fraction of the Sun's energy, achieving this level of energy harnessing is a distant goal. Many theoretical structures have been proposed to capture the Sun's energy, but reaching this level of capability is far off. The third stage of civilization is a Type 3 civilization, which has mastered the galaxy and can access any planet within it. However, we haven't detected any such civilizations, which is puzzling. The universe is 13.8 billion years old, while Earth has existed for only about a third of that time. There have been at least 5 billion years before Earth's formation, during which civilizations could have emerged and vanished, yet we see no evidence of them. For comparison, if you built a spacecraft capable of traveling at 10% of the speed of light, it would take about 600,000 years to cross the galaxy. While this duration seems long, it's trivial compared to the Milky Way's estimated age of at least 10 billion years. Thus, if it were straightforward, one civilization could explore the entire galaxy. So, why haven't we observed any? This could suggest that the Great Filter lies ahead of us. The Great Filter theory posits that there are significant barriers to the development of advanced civilizations, which might explain our current lack of evidence. Imagine there are 1 million civilizations in the Milky Way galaxy, but not all of them can dominate the galaxy. There are obstacles they must overcome. The first barrier might be developing multicellular life, which could be relatively easy to achieve. The next barrier could be the emergence of thoughts and consciousness. After that, understanding basic technology might be manageable. However, discovering time travel is a more challenging hurdle. There are unknown factors that hinder our progress toward becoming a galactic civilization, and we don't fully understand what these barriers are. There are hundreds of billions of planets in the Milky Way, yet we've not found evidence of other life. The Great Filter theory suggests that there are specific stages a species must overcome to dominate their planet, solar system, or galaxy. Similar to the Kardashev scale, some of these stages may be extremely difficult or even impossible to surpass. The key question is whether we've already passed this barrier or if it lies ahead. If we've already overcome it, we might be one of the first advanced civilizations in the universe. If it's still ahead of us, we face significant challenges in our path to becoming an advanced civilization. For most of human history, the fate of the planet was influenced by uncontrollable events, such as large asteroids that could wipe out life. However, in the past 80 years, we've developed technology capable of ending human civilization at any moment. We're advancing toward creating superintelligent AI, which could present significant challenges. If we discover an advanced civilization that failed while progressing, it might indicate that the Great Filter lies ahead, a troubling sign. The Great Filter is a barrier that eliminates almost every species that encounters it. It doesn't just reduce populations, it eradicates entire civilizations without leaving room for recovery. Many people fear entities perceived as stronger, such as superintelligent AI or aliens. Historically, encounters with more advanced species or technologies have often led to the downfall of the less advanced ones. For instance, the interaction between humans and Neanderthals or the European exploration of North America illustrate this trend. Given this history, first contact with aliens might pose significant risks. A crucial question arises: if we detect an alien civilization, should we reveal our presence? One perspective suggests we should, but another warns against it. It's possible that advanced alien civilizations have already detected us, but are choosing to observe us from a distance, waiting to see how we develop. They might view us as a science experiment on a galactic scale. While it could assist us in exploring the galaxy and encountering other life forms, it also carries risks, such as the potential extinction of our species. For instance, if superintelligent AI views extraterrestrial life as a threat and tries to eliminate it, it might fail, leading to a dire situation where our own creation becomes the cause of our downfall. If AI becomes too powerful, we can always shut it off. Imagine 3 other civilizations doing the same with us. They might be observing to see how life forms develop power. If we reach a critical point, they might decide to end their experiment. It might sound unbelievable, but this happens on Earth. There are places we don't inhabit, not just because it's inconvenient, but because it's inhospitable. Take Antarctica, for example. It's an entire continent that remains uncolonized due to its extreme cold and unsuitability for life. This might be how alien civilizations perceive Earth. They could have discovered us, found nothing remarkable, and moved on. It's also possible that Earth has been visited by aliens in the past, though not recently. Considering the vast time before Earth's formation, there could have been civilizations that encountered our planet during its early stages, when life was sparse. Modern humans have only existed for about 50 to 100,000 years. 100,000 years out of 4.5 billion is almost negligible. In a galaxy, there'll certainly be areas that are not worth colonizing. It doesn't make any sense to invest time and resources in a planet that offers no benefit. Aliens wouldn't come to Earth without a compelling reason, whether it's beneficial or harmful. Drake's equation is simply an equation, and its terms, especially the last one, are educated guesses at best. When tackling a question of this scale, that's all you can do. There could be many more civilizations than we estimate, or we might be the only one. If any value in Drake's equation turns out to be 0, it means we are alone. Calculations using Drake's equation vary widely, from predicting millions of civilizations to suggesting we're the only one. Both possibilities are currently valid. Enrico Fermi posed one of the most significant questions in human history, and he was also a key figure in the development of nuclear weapons. The same species that cannot inhabit the entire galaxy also has the potential to almost completely destroy itself at any moment. We actively search for signals from other civilizations. This includes looking for techno-signatures, which are signs of engineering or anomalies like city lights visible from space. We examine biosignatures in the atmospheres of exoplanets to identify elements that might indicate the presence of life. We also send out radio waves in hopes of detecting extraterrestrial signals. In 1974, Frank Drake sent the Arecibo message to the M13 star cluster. The message contained information about humanity, hoping that someone or something would find it. We also send out satellites like the Voyager probes with details about who we are, what we are, and where we are. We are actively trying to find alien life and providing all the information they might need to find us. Our desire to not be alone in the universe sometimes overshadows the potential consequences of discovering we're not alone. Are we at the end, or just at the beginning of human existence? The Earth has a limited amount of space for life, and we only have one option for expansion. One of the intriguing aspects of the search for extraterrestrial life is how we might eventually make contact if we find it. The nature of this contact could significantly impact both our understanding of the universe and the future of humanity. If we do detect a signal or encounter an advanced civilization, it's essential to consider how we would respond. Should we actively try to communicate, or should we remain silent? The risk of revealing our existence to potentially hostile or indifferent entities is a concern many scientists and philosophers have debated. Moreover, the absence of detected extraterrestrial civilizations might suggest that the conditions for developing advanced life are exceedingly rare. The Fermi paradox and the Great Filter theory offer explanations for why we haven't found evidence of other civilizations. If advanced civilizations are exceptionally rare or tend to self-destruct, this could explain why the universe seems so quiet. The search for exoplanets in the habitable zone around stars, the study of extreme environments on Earth, and the ongoing development of new technologies all contribute to our understanding of these possibilities. The potential discovery of extraterrestrial life would also have profound implications for philosophy, religion, and human society. It would challenge our views on our place in the universe and potentially unite or divide humanity depending on how we respond. International cooperation might become more crucial as we face the challenges and opportunities of such a discovery. Additionally, advancements in technology, such as more powerful telescopes and faster computing, could enhance our ability to detect alien signals or probe deeper into space. Projects like the search for extraterrestrial intelligence and the development of new space missions could increase our chances of finding evidence of life beyond Earth. These efforts are driven by both scientific curiosity and the fundamental desire to answer one of humanity's most profound questions: are we alone? So, what are your thoughts on this? Let us know in the comments below, and stay tuned for more videos.